For number 2 on 2019, this is a problem that you should have done on your own. If you haven't, please push pause, go back and do it on your own, and then come back and grade yourself. For number 2, we're given a table, and it says the velocity of particle P moving along the x-axis is given by the differential equation V of P, where V of P is measured in meters per hour, and T is measured in hours. Select values of V of P are shown in the table above. And then it says particle P is at the origin at t equals 0. So we can see an initial condition of 0, 0. So again, going back to the idea of the different types of FRQs, this is a particle motion problem, but we find it as a table here. So it's good ways to see different representations of different types of applications. And so it gives us a lot of good practice with that, and that happens a lot on the AP exam. All right, part A, it says justify why there must be at least one time in that interval for which V sub P prime of t, the acceleration of particle P, equals 0. Now, we're looking for on the interval 0.3 to 2.8. Again, because it says we are looking for a time, we are looking to see if there is a time on an interval. That brings to mind all our theorems, intermediate, extreme, and mean value theorem. Because we are given information about velocity, and it's asking for information about V prime, or the acceleration, this is going to be a mean value justification. So the first thing we have to do is figure out where if the average slope is equal to 0 over that interval. So if I take the slope over the interval 0.3 to 2.8, you can see that the velocity values are the same there. So we'd end up with 55 minus 55 over 2.8 minus 0.3, which is ultimately 0. And then to justify why we have a time where the acceleration is equal to 0, we have to go through the requirements for the mean value theorem, the hypotheses. So we have to explain, for the mean value theorem to work, we have to know that the function is continuous and differentiable. Well, it says that V of P is differentiable, so we can say that. And because V of P is differentiable over that interval, it is also continuous. You can't have a differentiable function that is not continuous. So as a result of this, we can say the mean value theorem will apply. And since we have shown that the average slope of the velocity, or we'd say the average acceleration, is 0 over that interval, then there is a time when the acceleration, V prime of t, will equal 0 as well. All right, points for this, you're going to get 1 point for your difference quotient. So basically 1 point for setting up the slope formula over that interval and getting 0, and then 1 point for your answer with your justification using the mean value theorem. Remember, you can't get this last point unless you state that the function was differentiable and continuous. If that's missing, then we don't know if the mean value theorem will apply, and therefore we can't answer this question without it. All right, for part B, it says use a trapezoidal sum with 3 subintervals indicated here, so that's kind of nice, to approximate the integral from 0 to 2.8 of V sub P of t dt. So we're looking for a trapezoidal sum. So remember, the area of a trapezoid is 1/2 base 1 plus base 2 times height. And so our first interval, we would say is 1/2 of, oh, I didn't put any pauses in here, I'm sorry. It's going to be 1/2 of, the first height is 0, so 0, and then plus our second height, which is 55, okay, and then times our height of the trapezoid, because we're kind of laying it down, times 0.3 here. So that is the area of the first trapezoid. The second trapezoid is going to be 1/2 of 55 plus negative 29, then times 1.4. Okay, now The reason it's 1.4 is because the distance from 0.3 to 1.7, and then these two values are our two bases, base 1 and base 2. Our next interval is going to be from 1.7 to 2.8, so it's going to be plus 1/2 of negative 29 plus 55, and then times the difference between 1.7 and 2.8, which is 1.1. Now notice we were doing 3 subintervals for the integral from 0 to 2.8, so we don't want to include this last one, and a lot of students will just go through, oh, they said trapezoidal sum, so I'm just going to do a trapezoidal sum. Please make sure you're reading the prompt to make sure you understand what you're doing. It says 3 subintervals, so we should have 3 trapezoidal areas. Then we can simplify all this to 40.75. And then again, note, you're going to get 1 point for your answer with the trapezoidal sum. So I would really be cautious here in terms of what you're doing. You have to have the trapezoidal sum correct, and you have to have your answer correct to get the point. But if you just had the trapezoidal sum without this simplified answer, you would still get the point. So it's better to just leave it unsimplified as long as all those values are the same, or as long as all those values are correct. All right, for part C, it says a second particle Q, also moving along the x-axis, given by, the velocity is given by v sub q of t as a function. Find the time interval during which the velocity of particle Q is at least 60 meters per hour. So we are looking for when this velocity, it's given, is at least 60 meters per hour. So what I'm going to do is, as far as work goes, is I'm going to set the velocity equal to 0 to see when the velocity is 60. Sorry, not set it equal to 0, set it equal to 60. I'm going to set the velocity equal to 60 to see the time when it is 60. And I'm just going to use my calculator. So I'm going to type y1. I'm going to use y1 for this function. And then y2, I'm going to use 60. So the 45 rad t blah, 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 blah is y1. And then 60 is my y2 function. And I'm going to look for where those two intersect. So that graph, roughly, this is very rough, looks something along this line. There's the graph of the velocity, and then there's my constant 60. Something along that line. Now, when I go to graph it, I'm going to find out where they intersect. So they're going to intersect at this point and this point. So use your intersection function or operation in your calculator and get those two time values. Now the question is, when is the velocity greater than 60? Well, we can see it on my cheap little graph that the velocity function is greater than 60 over the interval from this time to that time. So we can say that the velocity is greater than 60 over the interval 1.866 to 3.519. So that answers the first question about finding the time interval for which the velocity is greater than 60. And then the next part of the question, it says find the distance traveled by the particle during that interval. So if I want to find the distance traveled, remember that is the integral of the absolute value of velocity, and we're looking at these bounds because it says over that interval that we have there. Now I do want to note that in this particular case you didn't need the absolute values because the velocity is always positive in this interval because the velocity is always above 60. So the total distance traveled and the distance traveled in this case will be the same. But typing this into your calculator, you get 106.109. And so point values, you're going to get 1 point for having the correct interval. So 1 point for this answer here. And then 1 point for your correct integral expression. Okay. And then 1 point for the final answer. So 1 point for having the correct integral, and again, if the absolute values weren't there, this would still be valid because the velocity is strictly positive in this domain. And then 1 point for your final answer. All right, for part D, it says at time t equals 0, particle Q is at position -90. Using the result from part B, and the function v of q from part C, approximate the distance between particle P and particle Q at time t equals 2.8. And so this this sounds complicated at first, but it's really not that bad. We are looking for the distance between the two particles at a given time. Well, in order to know the distance between two things, we need to know where those two things are. In other words, we need to find the position of those two particles at that time. So if you remember, the position equation is position equals our initial position plus displacement. And displacement is the integral of velocity. And so the position of particle P, we'll call it x of P, the position of particle P at t equals 2.8 is, well, we knew that particle P was at the origin at t equals 0, so it's going to be 0 plus the integral from 0 to 2.8 of the velocity of P. Okay, so this is giving me my position of particle P, initial position plus displacement. And then when I already did the work to find or to estimate the integral from 0 to 2.8 earlier, and so that was 40.75. For the position of particle Q at 2.8, we need our initial position, and in part D it gave us our initial position of negative 90, so we're going to say negative 90 plus the integral from 0 to 2.8 of the velocity of Q. And so again, make sure our initial time matches our initial position. And then from here we're just going to type this into our calculator because we have the equation for the velocity of Q. Don't forget to add the negative 90 there, and you end up with 45.938. So now we know the positions, both the positions. How do we figure out how far apart they are, the distance between them? We're just going to subtract those two values. And so the distance between them will be 5.188. Points for this, you're going to get 1 point for knowing or setting up having the equation, the integral from 0 to 2.8 of v of q dt. So basically if you had this, where is it? If you had this guy anywhere in your problem, you're going to get that 1 point. You're going to get 1 point for the position of particle Q, so 1 point for this position here, and then you're going to get 1 point for your final answer of 5.188. All right, so that wraps this one up. Go ahead and grade it, and then we're going to jump into the next problem. So that was question number 2019, number 2. Your next problem is going to be a quiz problem, and that's going to be question number 4 from 2018. This is a non-calculator problem. So set a timer for 12 minutes. Do what you can with it. Please do it with integrity, and then come back and grade it watching the next video.